Our next speaker, Raj.
Hello. Hi. Thank you very much for coming to my talk. I'm really humbled to be, invited and standing in front of you, giving this talk here. Thank you. I think I win for the longest title for a presentation. I'm hoping to basically meet that. So how many guys here do work with Lambda or functions Lambda? Azure functions? No Azure functions? Google functions? Oh, right. Google functions pretty new. I'm going to basically cover bits of everything. There's 1 hour. I've got a couple of demos. Hopefully the demo gods will be on my side. And I'm going to go through a presentation, take you through a story, hopefully, and sell you why you should be using functions. So I'm an engineer, like everyone here. None of this is my material. I work in teams, so a lot of this is what I've learned working with, my friends, with my colleagues. So I'm just here sharing what I've learned. I'm not an expert in serverless, but I've been doing serverless for a long time. I don't think you can be an expert. It's changing all the time. Right now we have reInvent, and there's new stuff coming out all the time. But I've worked with the 3 technologies here and been doing that for a while. And I'm hoping by the end of this, you'll be working with all these 3 technologies. So I have 2 jobs. I work at a company called Equal Experts. We work with big companies, introduce serverless, or move into a kind of a more agile world of delivering software continuously. But I've got a little startup on the side, Baco.com, and what we do is we take all the little merchants who do the best wines. They sell the best wine, but they don't know anything about SEO. They don't know about selling online. We give them a platform, so you can go to Baco and buy wine, comparing, it's a marketplace for wine. And it's all built using Azure functions, Lambda and Google Cloud. And I'll take you through the story just now. So my journey to serverless, I used to be a C++ developer years ago on Solaris, and used to write software for power plants, and used to be 1 server in there, and it was a baby. You had the server, write software on it, right, run a power station. It never went down. It was amazing. Things changed. Windows came along, and you had Windows servers, we still wouldn't have Windows servers in power stations. You can imagine why. But then, virtualization came along, got onto that wave. Then Azure. We were the first guys to be on Azure, so we were the classic Azure. We went through a lot of pain there. 40 minutes deployment time. That was amazing for us. It was a big change. AWS come along, did work on AWS, EC2, CloudFormation, Terraform. Right now, it's more serverless. That's where I spend most of my time. And a bit of Kubernetes, Docker, bit of EC2 as well. Serverless is not for everything. So it's been a journey. And I think if you really want to appreciate serverless, you need to have been doing this. You need to go on this journey. You need to have built software that's, big things to deploy. You need to have done infrastructure as code. You need to have written CloudFormation. Anybody here written CloudFormation? How painful is it, man? So you need to do that, right? You need to build AMIs. We did that. You need to set up deployment pipelines and, push, test, deploy AWS. Code deploy is before code deploy. Imagine that. And you need to control costs in an auto-scaling environment. This is when things go, you need servers everywhere. You need servers in each availability zone across, regions. And then you've got to make sure you can control costs as well, because all these servers are sitting there running. So my first introduction to functional programming came, I was having wine again with a friend, and we were talking about domain-driven design. Guys here familiar with domain-driven design? Anyone? Yeah? So there's this book. So let's start with this story. I was sitting doing C#, C++ at that time, and my friend came along and goes, you need to try F#. I goes, really? What's that? And, function programming language. And we started looking at it, thought, what's the best use of this? And if you come to domain-driven design, this is all about understanding your business, having one ubiquitous language, and having a core domain that's pure, that basically you can define, that's your business, right? This is your core domain that brings you money, right? This is your core domain. The rest of it kind of doesn't matter. So we came to the conclusion that actually we could define our core business in F#, and everything around it, infrastructure services, could be in C++, C#. And this was before I read this book. And this is kind of Eric Evans' book. Anyone read this book? Yeah? Very good book. And what Eric Evans says in this book mainly is focus on the domain and the domain logic rather than technology. And this is where things, if you look at companies, the best engineers should be working on the bit that brings money to the business. That's what he says in the book. But you find the best engineers are not working on that. The best engineers are actually solving infrastructure problems, because actually it excites everyone, doesn't it, to solve infrastructure problems. So you find in a company they put all the best engineers to solve all the other issues, right? And the new developers are sitting there writing a lot of the business logic. And it's very clear in his book. He goes, the core domain is the domain which makes your business unique and give you an advantage over competitors. So put your best engineers on the core domain. The other bits, so a generic subdomain in his context, and there's also infrastructure services, handles a topic that is still important, but you can find another solution. It's not the bit that makes you money, right? You can find open source variants, you can find other tools for it, right? So put your best engineers on the core domain, and the other bits, just bring them in. So this is one of my learnings over time, is like, what rots? If I look at, through my time, even on a .NET project, let's say, new libraries come about. We move from kind of, .NET Framework 2, 3. What we're changing there, you'll find that is a lot of the infrastructure. But the only time the domain logic changes is when your business changes, right? So ideally, you want to be basically working on the business logic. The infrastructure code, that changes all the time, right? So spend more time doing it on your domain. So I took a real problem. So Baco.com, the wine company, that a wine little startup I've got with my friends. We have a real problem here. So we have merchants who upload images for wines to our website. They upload the images, but there's a couple of issues with these images. Some of these images are really bad images, and we don't want to show these images to our customer. Sometimes the image is not the wine bottle itself, but it's actually another bottle of wine next to what we're selling. Sometimes the image doesn't contain a bottle of wine. It doesn't contain something completely random. And what happens is one merchant can come in and upload a really good image of wine. Another merchant comes in, overwrites it, and we end up with a bad image. So we wanted to solve this problem. So if you go to Baco.com, which is here, you can basically search for wine. A lot of it is running on Azure, the front end. And you'll see that we've got like replacement images, right? We have a lot of issues with images, and we're trying to solve a lot of these issues. A lot of these stem from the fact that these images are not very good. So I thought, let's solve this issue, and let's find out how we're going to do this. So I came across Amazon Recognition. Who went to the Google machine learning talk today? Yeah, that was quite interesting. I think Amazon have a solution that's called Amazon Recognition. You give it a picture, and it puts like labels with some kind of level of around how accurate it can identify objects in that image. And Amazon Recognition is pretty good at that. There's another software that is called Microsoft Cognitive Services Optical Character Recognition. What this does is you can give it an image in any direction, and it can actually read the text from those images. So I thought, why don't we combine the two, right? Give it an image, see if it contains a bottle of wine, if it does, and see if we can read the label of that bottle of wine. And if we can, and if it's a good quality image, we can basically put it on the website. So how could it work? We thought, this is a nice, we've already got a merchant app. What we'll do is get the merchant to upload images. We'll store the images somewhere. And then we'll spin a worker in the background that will get the images from that store. It will see if it's a wine bottle. If it's a wine bottle, that's good. It will forward it to another worker. Standard, right? And then that worker will, or maybe write it in database, that worker will talk to the database and he'll say, okay, yeah, I've got a wine bottle. Let me read the label. I'll go to Cognitive Services, read the label. It's good. Let me forward to the next guy. The next worker picks it up. He publishes to Baco and sends a notification via Slack that actually there is an image there. So the concept seems quite simple, right? So what does it look like? I mean, we've got choices as well. You know, Baco is on Azure, and bits of it are on AWS. So what do we choose? Google, Microsoft? Actually, why do we need to choose, right? So your customers are buying wine from you. They're not buying wine from you because you're on AWS or you're on Azure or on Google. They're buying wine from you. So why not give them the best service? And if what we do is we combine the best of every platform. And actually, we combine the free bits of every platform. So we kind of run that whole website for very, very cheap, because actually we leverage a lot of the free services and actually leverage all the best services across the platform, and we provide an environment. Yeah. So exactly, your customers don't come to you because you're on Azure. So remember what Eric said? Focus on the domain and the domain logic than technology. Yeah, technology doesn't matter. We're trying to solve a business problem here, right? Let's look beyond that. So if you had to design it in a monolith way, one application where we just deploy the whole thing, it will kind of look like this in AWS. We'd have an auto-scaling group. Of course, we got to provide HA, right? Auto-scaling group, that's a website, hosts a website, and it could actually write into a database, maybe DynamoDB, maybe SQL, and then something else pulls, a worker in the background picks it up, and then does all the bits and pieces it needs to do. Talks to recognition, talks to cognitive services, and sends it forward. Not bad, right? But what do I need to do? I need to solve all these things. So I need Terraform for the VMs, if I do it properly, right? Do I use containers, Kubernetes? I need to think about bootstrapping, these images, DSC, AMIs, auto-scaling. I need to think about auto-scaling, right? What if I get lots of people using, if my merchants go up by 1,000, what do I need to do, right? I need to deploy across availability zones. I need logging, monitoring. Do I put an agent on the boxes to log ship, right? That's what I need to do, because I need the logs if some things go wrong. Monitoring, I need monitoring. I also need to set up CI, deployment. I need to get my code on those boxes. And also need to think about testing, right? But then you got traditional microservices, which if I go for this model, so I can split things up. I've got the web server, auto-scaling group, and then each bit is responsible for its one single responsibility. So web server auto-scaling group puts stuff into the store, SNS, SQS, pub sub, right? Something picks it up, a worker goes to recognition, forwards it on. The next guy picks it up, cognitive services. Eventually, a service puts it into Slack. So this is kind of the microservices equivalent of that. But I still need to sort of solve all those issues. Plus, I need HA across availability zones for each service. So whereas I had 3 servers in an auto-scaling group across 3 availability zones, now I've got, for each service, I've got 3 servers, right? Minimum. I need to solve security as well, because now the servers are talking to each other, right? I need to think about licenses, costs, because now my code's spread across the infrastructure, right? And I think about testing, it gets more complex, right? Now I had a monolith, now I've got to test microservices, right? And what about authentication? Yeah, actually, what about authentication? How do we solve authentication? So there is OpenID Connect, OpenAuth 2, and this is pretty standard. Anyone here familiar with OpenID Connect, OAuth 2? Yeah? It's simple. You go to an identity server. That identity server has one job. It goes and talks to other providers. So I want my merchants to log in with their Google accounts, or I want them to log in with their social, but I actually want to make sure they are those merchants. So what do? I need an identity server. Anyone here worked with identity server? ThinkTexture, right? Good solution. So yeah, I can put a server there, runs the identity server. That server, when someone logs in, it directs you to that server. You log in, gives you a token. That token, then I can provide a token to all my services. And I know it's a merchant logging in, and I know that merchant user is the guy who's actually going to be uploading. So I need to solve that, because I can't really keep my services open on the internet. Right. But remember what Eric said? Focus on the domain and domain logic rather than technology, right? At the moment, all we've been talking about is how we're going to build this. What does the environment look like, right? So enter serverless. I'm going to talk more about functions as a service. So what is functional programming, right? So if you look at functional programming, anyone here doing functional programming? Yeah? F# or... It's basically, it's based on premise of computation of data. Data comes in, data comes out, right? There's no side effects. Simple, right? That's a function in the functional programming world. But if you look at AWS, Lambda, Azure, and cloud, they're just stateless functions, exactly like a functional programming world. So whereas functional programming is at your code level, you can look at functions as a service as functional programming at the architectural level. What I'm doing is hooking up functions, right, in an architectural way. And I'll show you how you can do that to solve that problem. Right? So let's do a brief overview of the guys who actually don't know the other platform. So AWS Lambda, right? So what is AWS Lambda? Allows you to run code, little function, it's stateless. There's two types. So you get events. So if you put something call an HTTP service, right? It will call you Lambda. That's a synchronous event, and it has some characteristics because it has to return directly, right? So you call an HTTP endpoint that calls a Lambda, returns data, right? If you do asynchronous, for example, I put stuff into S3, S3 will call that Lambda, right? So it's not me calling that Lambda. I just get the Lambda to work on the event. And that's kind of works on an asynchronous model, because what happens is, in that world, if S3 calls my function Lambda and something goes wrong, S3 knows how to retry and call my Lambda. So that's all built in, right? That's an asynchronous model. And you need to learn this when you work with Lambda, because Kinesis, S3, SNS, they all kind of have their characteristics and how you write Lambda functions for them. With Google Cloud, it's actually very similar to AWS Lambda. Same thing, but Google Cloud actually is just a wrapper on Express. So whatever you can do with Express, any Node developers here? Node.js? It's just whatever you do with Express, the objects are exactly the same. It's just that, but it's very similar to Lambda. The only thing you can actually use in Google Cloud is Node.js, whereas Lambda, I'll give you a taster of what you can run. You can actually write C#, .NET Core, F#, right? So if you want to write your code in F#, but Node.js is technically what I'm going to be using, because I'm going to be coding across the three. Azure Functions is a bit more than Lambda. So Azure Functions have triggers and bindings as well, right? Functions, which are events, and this thing called bindings. So let me give an example. For example, if I call a Lambda via an HTTP event, and I want that Lambda to write to S3, the output, I have to write code to write to S3. Whereas with the AWS function, Azure function, what I can do is, if I give it an input, HTTP, I can say, when the Lambda outputs, I want the binding to write it to a table. So I actually never write any code to say, write it into a table. It's basically the output of the Lambda can be piped into a table, which is pretty interesting. That's your bindings for you. And the whole thing about Azure is that when you write a Lambda in AWS or Google Cloud, it's one little function, it's on its own. All the settings are around it. Where in Google functions, and Azure functions, sorry, you write the whole set of functions in an application. And the application has two properties. So you can have the application to be like Lambdas, spin up on demand, or you can say the application runs longer. So Azure functions are the only ones you can run things longer for, forever potentially, right? Long-running jobs, they support that. Lambda and Google functions don't. They're very short-running jobs, and I think it's a good pattern. So, what would the solution look using serverless, right? So please don't get scared. There's a lot of objects here, but these are little functions, right? So the orange bits in there are little pieces of code, right? The bits around it are the bits it touches, right? So it's not really a lot of code. Let's look at each one, right? So you got the machine that to upload a file, right? What we have to do is request a signed URL, right? So we have an HTTP endpoint that you talk to, gives you a signed URL, which is an S3 URL, and I can actually upload the object to S3. So what a merchant can do is he goes to a single page app. The single page app returns a signed URL, uploads to the signed URL. It's very secure. Writes to an S3 bucket. Now the S3 bucket, there's a Lambda. So that's the upload. There's a Lambda that subscribes to the events of S3. So when you write, so this is the difference. In other applications, you would be polling the S3 bucket. But here, the S3 bucket, writing to it calls your Lambda, right? So my Lambda is sitting there waiting for events. As soon as I put something into S3, my Lambda kicks off. It calls Amazon recognition and says, okay, do you know what? Is this a wine bottle? And this is where my business logic is. My business logic is, if it's a wine bottle, then publish it to SNS. I publish to SNS, and when I publish to SNS, there's a couple of Lambda functions that are subscribed onto that event, PubSub, right? So as soon as I publish to SNS, one guy takes the data that's coming through the SNS, goes back to S3, and writes tags on the object. So that's my database. So there's no database involved here. So one Lambda listens to SNS. When it finds out there's this bottle there, it'll go and write it. Actually, no, it writes everything. And then a bottle detector, Lambda, every time it gets a bottle, it'll forward it to Azure. So what happens on Azure is the other story. So this is my merchant image scanner. On the other side, I do the same thing. My Lambda is going to talk to Azure. It's going to get a URL for writing into the bucket, which is a signed URL. That means it's just valid for that. It's authenticated. I get a URL and I write into bucket. My Azure function, which is based on the event on the bucket or on the blob storage, it's called. It's going to pick up that event, call Microsoft Cognitive Services, and then forward it on. Another function is going to pick it up and then send a Slack notification to Slack. So I've got a Slack channel. Let me bring that up. Okay, images. Right, we're going to write into that bucket there. Okay, so what about auth? So what about auth? Yeah, so I can solve that in a serverless way. So I'm going to talk to auth 0. I've got an Aurelia app. We'll run this demo. It's going to talk to auth 0. I'm going to log in with a Google account. And what I write in my Aurelia application is this thing, another Lambda called an authorizer. All that's going to do is validate that the token that comes from auth 0 is valid. And if it's valid, it sits in front of every Lambda. And it's going to, if it's valid, it's going to continue. Otherwise, it's going to throw a 401 or 403. let's look at the demo. So let's look at some code. So I've got here using serverless framework. So on the left is an Azure function. On the right is, can everyone see this? Yeah. So here I have the Lambda. And what you have here, I've got a provider called Azure. So one Git repository that I can actually push into Azure, AWS, and Lambda. So the bit that does the pushing is called serverless. The code's very similar, but this is the bit that is different, is how I declare the Lambdas, right, or the functions. So in here, I say this is my Azure provider, that's my Lambda, that's the AWS, that's my Node.js, right? This is my region. So at the top, it's very kind of Azure specific. These are my keys. And at the top here, that's very AWS specific. So it says, look, only allow my Lambda to talk to the bucket and publish SNS messages and talk to recognition, right? These are my functions. So there's my plugin for Azure Functions. These are my functions. I've got an image scanner, I've got a tagger, and I've got a label scanner. We'll look at some code in a bit, but let's do the demo, right? And I've got my functions here, label reader, right? And if you look at this, in Azure, I have to exclude node modules. In Lambda, I don't need to. The difference here is when you push into AWS Lambda, you build the software, the package, and you upload the zip file. Whereas Azure doesn't actually do that. What Azure does is it looks at a Git repo, it checks it out on the box using Kudu, and then builds your software on the box, on their box, Lambda, right? So that's the difference. So Google Cloud and AWS, you build the software, you build the zip, push it. Whereas Azure Functions is built on the fly. Okay, so let's look at demo. So I built this little single page app. It's hosted on S3. I will be sharing the code for this. You can run this yourself. And also, that's actually, you can log into that. So I'm going to log in through Auth0, okay? And I'm going to log in with a Google account. So within Auth0, you can choose providers. And I can create little lambdas that validate whether this person is a merchant or not. In this case, I'm not. What I'm doing is basically just saying provide Google. So I'm going to go to Google. It's going to validate Google and log me in. So what I have here is I'm logged in. I'm going to upload some images. So the end result is that within this Slack channel, I should see everything, right? So let's upload some images. So I'm going to upload a banana, right? This is where the demo gods, thank you. Please do. Let's try again. Let's refresh this, okay? I think we have a network issue. Okay, uploaded. It's a bit slow. I think the Wi-Fi is a bit slow. I'm going to refresh that. That discovered tags there is what comes out of Amazon recognition. So I uploaded a banana. It told me that's a banana. Simple, right? I'm going to upload a couple of wines, actually. So I'm going to go that wine. That's a label. Okay. I'm going to add something else. Let's add Rioja. Wine drinkers here. Browse. I'm going to add Darth Vader. I thought Darth Vader kind of looks like a bottle of wine, the picture, right? So let's see if Amazon recognition gets that right. Okay. I'm going to add another bottle of wine. Personalize. Yeah, this is a couple of bottles of wine. Let's see what it thinks of that. So this this column here is what Amazon Recognition is thinking, and these are the tags on the S3 object, right? So you can see that Darth Vader was not a wine bottle, right? It's kind of an interesting clothing, hoodie. We got banana there. We got bottle and alcohol. And let's add another one. I think I've got another one there, which is going to be Ryoka, personalize. Yeah. Those. Okay, so refresh that. Let's look at Slack channel. Nothing there. So what's happening here? Let's look at logs. Actually, there's probably same issue. So I can actually go to CloudWatch and view the logs. Or I can tail the logs locally. So I'm going to tail the logs here. And I can see that it's received an event from SNS. The Lambda kicks off. And it found a bottle in the picture, which is brilliant, right? But it's getting error messages from Azure. For some reason, Azure's broken. And I know why. So this is one of the challenges of Lambda, in a way. If your Lambda doesn't get called, what happens is Azure or AWS will spin down the containers, so the containers won't be there, right? When you call your Lambda, the containers spin up, right? And basically, you should retry, but I don't have any code in here that retries the Lambda. So there's zero retry logic. What AWS Lambda and Azure gives you is free retries for the asynchronous code. And it also gives you a dead letter bucket, which means that dead letter queue, sorry. If I fail many times, I can write to a dead letter queue, and then I can recover from that scenario. And that's free. That's out of the box with Lambda. You don't have to write code for that. Okay, so it's going to fail a couple of times. The Azure function's going to wake up, and then it's going to try, and we'll see some notification. But what we'll do is let's continue a bit, right? Okay, let's look at some code. Actually, let's look at another thing, is how does authentication work? So if I look at uploads get, you'll see that in here, I'm sending a bearer token. So the bearer token is what I got from Auth0. My Lambda, which is an authorizer. Let's look at authorizer code. What does the authorizer code look like, right? So if I look at in here, that's the same one. Authorizer, that's it. So what I'm doing here is I've got a function there called an authorizer, and for my list uploads, I'm just saying actually use that authorizer, call it. It's just another function, right? I define it once, and I just hook them up together. So I have authentication, right? Let's continue. We'll come back here. So hopefully, there you go. I have some wine bottles. So if you look at this, it says, OCR, discover the following text. It's got like, tells me it's, the language. Tells me the label text, right? It's found all these out of that bottle, right? In here, it's told me, that's another bottle there, right? And that's the language out of it. So basically, this is Azure and AWS working together, right? And you could potentially forward it onto a Google function and do something smarter as well. So what do I get for free? I get all that, right? I didn't have enough space on the slide. I get HA. I highlighted security because when you deploy a big application, right, you have to give that application all the security. But if you're deploying a function, you're just giving that little function enough security for that function to operate. So you're actually not opening up a lot for that function to do. It's least privileges. Limits. So AWS gives you 1,000 concurrent requests out of the box for Lambda. That's a soft limit. You can ring AWS up and say, by the way, can you increase that? Right? So out of the box, you make sure that you don't do something silly and end up with a big bill. Durable storage. And I don't retries. I mentioned retries, dead letter queues. You get that for free. So imagine you don't have to write code for that. So what is focusing on the code business problem? It's basically, I could have easily put up a development team and got them to write Amazon Recognition or look at Google functions, or maybe I could have done a lot of the label scanning myself. But my business is selling wine, right? That is where I want to focus. I want to provide the best wine to my customers, and that is my focus. So I want to focus on that problem. The rest of it doesn't matter, and I'll show you the cost of this, right? So custom code, functions as a service, there's almost zero infrastructure code, right? There's no servers for me to manage. When I get scaling across availability zones, when I get more traffic, it scales up. All the code was 39 files and 1,320 lines of code, including the auth, right? So that's the whole project, which did all that work, okay? That includes the YAML files, everything. And it's pay as you go. This is the best thing about Lambda and functions is if your merchants don't use it, you're not paying for it, yeah? Whereas a server sitting there waiting for the merchant to upload is costing you money, right? And I believe the real cost savings from Lambda and Azure serverless is not when they're running, it's when they're not running. So if, when your servers, right now, so I used to work for a company that used to basically sell takeaways, and during the day, no one orders takeaways, but we had 600, 700 servers sitting there waiting for that first order, right? Because you need a server per availability zone, at least one, and you can scale up after that. So you can imagine when you're not calling Lambda, you're not being charged for it. Here's a cost comparison. I try to be really low on the monolith. That's £184. Serverless, which is mainly S3, $14, right? So it's like 7%. And I'm actually being quite harsh on these numbers. I'm trying to make serverless look worse than it is here, right? What about Amazon recognition? It's $1 for 5,000 images, $1 for 100 images for cognitive services, and Auth0 is just $0. I've got I would have been paying for an identity server myself, hosting it, right? And that will cost me in maintenance. This is how much I'm going to be paying. So that cost includes, $14 includes everything here, right? So there are serverless patterns. I'm not going to go through here because that's another whole presentation. There's lots of ways of solving challenges in a serverless way. So an upload is what you saw. Authentication is another one. There's event workflows, there's step functions. You can do little functions, event workflows with state, pub sub. There's a whole talk on this, right? So if you got time and you're interested in this topic, there's a lot of material out there. I'm going to talk about continuous integration now. This is how we work. Because the Lambda runs in Azure, you can run it locally. So I can actually spin up the Lambdas locally. So you can test everything in memory. So it's cheap, right? You can just spin up the Lambda. It's a function. A lot of it hosts in Node, and I can run it. There's C# versions as well of hosting locally. You can run it F5 in Visual Studio and run your Lambdas and write tests around that. So a lot of the tests we run are in-memory tests. We will spin up Elasticsearch in memory, run the test, spin it down. It takes about 20 seconds to spin up Elasticsearch with downloading it and running it. There's lots of things you can do. The other thing you can do with this is it's only costing me $14. So I can just spin up another AWS account and test it there, right? It's not costing me a lot of money just to deploy it and test it again, right? So this is our continuous integration cycle, right? So build, pull request, unit test, pretty standard. Deploy, smoke test, right? This is from checking in to deploying is 2 minutes, 3 minutes. But it doesn't stop there. So what we do is we have a lot of monitoring in place. And for if you're actually running Lambda, Azure, and Google Functions, that's a challenge to actually have a visibility across all your environments. We use a stack I'm going to talk about, and basically you want Slack and PagerDuty, and your CI stops here. Yeah, is a continuous delivery. It stops here. I'm continuously monitoring. Do I roll forwards? Yes, alerts going off. Alerts going off. We either roll forwards or revert. We follow TDD, we unit test edge to edge. Your function is input output, right? We spin up in memory, we spin up equivalents, and it's actually really cheap, right? What is our aim, right? This is, I believe, as an engineer, is to keep reducing cycle time so I can deliver value to production, right? My code, the more code I write, and I'm building up risk, right? If it doesn't end up in production. So little small pieces. When you're working in the Lambda world, you're writing little lines, 2-3 lines of code, checking in, it's out in production, checking in, and you can run little experiments. Because it's pay as you go, you're not committed. Even when you go for EC2, you sometimes have to save costs, go for reserve instances, and you're committed. You can't change, right? You got EC2 machines for the rest of the year. With Lambda, I can change my mind any time. I can say, today I'm storing stuff in S3, tomorrow, actually I'm storing DynamoDB, and it's pay as you go again, right? I can change my mind, and I can run little experiments really, really inexpensively, right? And I'm not committed to anything. But staying serverless is big learning. Once you start that, to stay serverless, because you come from a world that wasn't serverless, you end up in this world, actually. Every little feature is a new function. It might be a new endpoint, it might be a new store, but every time, little feature, its own function, and it just plugs in. A bit like Lego. Monitoring is key. You've got to do this whether you're running Lambda or not. A lot of the stack we've built up, this is where we do use servers, is Telegraph, InfluxDB, Grafana. We replace Chronograph with Grafana and Capacitor, and we harness CloudWatch metrics and App Insights into that stack, and we look at Google Analytics. And that basically, at the same time, what we do is we hammer the environment. So if we have in production, so this is not offline, so while our users are using the system, we actually hammer the system as well. This helps us understand, right, if we push some code out there and the traffic's low, at least our load tests are making sure our monitoring is going to kick in if there's some dodgy code which we push. And fake load running in production is highly recommended. Don't run it in another platform or another environment. In production is the best feedback you can get. And thank you very much. Right? If you guys want to look at some code, I'm going to post the GitHub repo, the slides. Please come ask me questions about any of these, the code that's here. I can dig in, help you out. Thank you very much. Questions?
All right, so I don't see any questions in the Slido, but maybe there are questions still that want to be asked. No questions?
Yeah. Sure.
Basically, Lambda initialization takes some time. So first initialization, how do you handle it in production?
So there's many ways of doing it. So the thing is, I spoke about fake load. We basically hammer our production environment. So this helps because you as a company, you're growing, and you need to know whether you're going to grow. And one thing you can do is keep hammering your production. Make sure you can get capacity. If something goes wrong, just kill the fake load, and it should handle the main traffic anyway. But Lambda, it's all about how you write the Lambda. If you bring a lot of dependencies, right, a lot of NPMs and a lot of dependencies, of course it's going to take longer to spin up. But it's only the first time after you deploy. Once you're deployed, what AWS does is it freezes your container. It's called freezing your container. So the next time it starts up a new instance, it will start up from the frozen container. If that makes sense, it's not going to start from scratch. So normally it's quite quick. Yeah, keep your dependencies low, and it should spin up really quickly. Where we found some delay has been the Azure example I gave you, right? Azure does take a bit of time, but Azure has 2 models. So if you're really critical, you're not doing asynchronous stuff, choose the other model. Yeah.
Thank you. Any other question?
Yes, sir.
You tried to do something serverless and saw that it just doesn't work.
Yeah, so the website is not serverless, so main website. Ideally, I would like to statically just offline, build it and deploy it. Right, the demo I gave was an S3 bucket with a single page app running. Ideally, when you're working against, let's say, Google, and you want to be, you're working with SEO and you want Google to index you, you don't want to work with dynamic content. You want a lot of the static content Google can find you. So I can see some parts of the site being Lambda It's not currently. We started that some time before when we were not very familiar with Lambda, and we are moving bits of it to Lambda anyway. But I wouldn't see all of it in Lambda. Lambda doesn't work all the time. For serverless is not for everything. You can do quite a lot of it, but there are some cases where if you're not event driven or you're not solving a particular problem, then don't go the Lambda way. I've seen some people try to use Lambda and they get into a twist because it's not really built for those scenarios. Yeah. So there are cases where you wouldn't use Lambda, right? A static website is an example. Yeah.